Hello and welcome to this first WebEx video presentation for Senior Design 1. This is a presentation for the Temple University NASA Lunabotics electrical team for the 2014 competition. And this is a WebEx posting that is that's due on Friday, October 4th, 2013. My name is Mark Halberstadt, and I'm the team leader for the Lunabotics electrical team this year. So what I want to talk about in this presentation is I want to introduce the team, the electrical team on the Lunabotics, give a brief overview of the competition, talk about the goals that the electrical team has for the coming year, talk about the overall progress that we've made thus far on the project, and then go over some of the next steps that we're going to be pursuing over Senior Design 1. So the team that we have got John Morris is an electrical engineer, senior electrical engineering student at Temple, and he is in charge of power electronics, power monitoring system, and circuit design. We also have Eric Schisselbauer, who is an electrical and computer engineering student with a computer engineering concentration. He's going to be working on computer architecture, control systems, and autonomous systems. And then you have myself. My name is Mark Halberstadt. I am an electrical and computer engineering student, and I'm the team leader, and I'm going to be concentrating on autonomous and control systems. And our advisor this year is Dr. John Helferty, who is a professor of electrical and computer engineering here at Temple. So the overview of our competition, we are going to be participating in NASA's 5th annual robotic mining competition, which is the Lunabotics competition. This is a university-level competition where teams design and build robots capable of traversing simulated lunar soil, excavating the regolith, so excavating, essentially doing a surface mining operation on top of that soil, and then depositing the excavated regolith into a collection bin. Where we are going to be doing this, pretty much we have a simulated lunar arena. And this is a visual representation of what it looks like. This is a visual representation which was provided by NASA. And it is about 8 meters by 4 meters, and these are the exact dimensions that we have. And pretty much what happens is we start in one area of the arena. We have to traverse an obstacle course. We have an obstacle course right here with craters and rocks. And then we have to excavate our regolith in the digging area. Then once we excavate, we have to traverse back over to our starting area, and there's actually going to be a collection bin over here where we're going to dump our soil, our excavated regolith, into the collection bin. And the soil that is used in the simulated lunar arena is BP1 soil. It's compacted BP1 soil. So an overview of the competition. The competition is scored based on points. There are a number of different ways that you get points. Generally, the large things that really where you can lose points in this competition have to do with the mass of your robot. And the main way that you gain points in this competition is by mining regolith. Another thing, as you can maybe see by the breakdown, a large number of points can be gained from autonomous operation. But there are a number of different ways to get points. The electrical team in particular, we are going to spend a lot of time this year concentrating on autonomous function of our robot, really going after a maximum number of these autonomous points. And as you can see, there are 4 different levels of autonomy, with 500 being that you operate autonomously for the full competition round. One competition round is 10 minutes. You pretty much get 10 minutes to excavate the maximum amount of regolith that you possibly can. So the electrical team goals for this year, our number one goal that we are that we are going to achieve is we are going to design and build power control and communication systems capable of piloting a mining vehicle through a harsh lunar environment. This is our absolute number one mission critical goal. We need to be able to support. We're working alongside with a mechanical team that's actually going to be designing the mechanical systems of this robot. And really, what we have to be able to do is we have to be able to support that mechanical team with electrical functionality for that robot. So we have to be able to power control and communicate with that robot. The second highest priority, and this is directly driven by the point breakdown as provided by NASA in the rules for our competition, is that we are going to achieve complete autonomous functionality of our mining vehicle. Our goal is that as soon as we enter our arena, we are going to give our robot a 1-minute countdown to autonomous function. And at the end of that 1 minute, the robot will begin operating autonomously, and we should not have to interrupt that robot from its autonomous function until the end of the competition round when we tell it to stop. That is our second highest goal. The third goal that we have as a team is to try to maximize our power efficiency as much as we absolutely can. And the goal of doing this is to really be able to reduce the size and weight of our battery system such that we can gain the maximum number of points, or really retain the maximum number of points by having as light a robot as possible. So in terms of the progress we have made thus far, we are part of the Student Space Exploration and Environmental Systems Laboratory run by Dr. John Helferty at Temple. And one of our largest accomplishments that we've had thus far in the term is we have really been able to set up this lab in a space where, to a degree where we will really be able to build the robot and deliver a highly functional robot over the course of Senior Design 1 and Senior Design 2, so over the course of this entire academic year. Another thing that we have accomplished is we have been able to implement a very simple power and control system on a testing platform. This testing platform was actually provided to us by a previous senior design team. This last year in the 2012-2013 school year, this was the result of the autonomous lawnmower project. So we're very grateful that they were able to loan us their project, essentially, for us to do testing. So we are going to be testing our autonomous system using this platform that they have very graciously provided to us. Another thing that we've accomplished is we've accomplished some preliminary tests using both Raspberry Pi and Arduino DUCE systems. This year we are planning on having our main control system be on the Raspberry Pi. We're hoping to implement as much of the control and autonomous system as possible on a Raspberry Pi. We are also going to have Arduino systems for some lower level processing and also for general purpose I/O and also analog input into our system. We have also accomplished some preliminary testing on a couple of different infrared sensor units. So we have completed testing on a Vishay sensor that's able to demodulate a 38 kilohertz infrared signal. And we've also completed testing on the PixArt sensor, which is in the handheld Nintendo Wiimote unit. We have been able to read information from both of these sensors into an Arduino board. So that is what we've accomplished thus far this semester. The next steps for the project, the next step is broken down into the different subsystems. For the power system, we are going to replace the motor controllers we currently have on our testing platform. Right now we have motor controllers that are built by the VEX Corporation. Currently the way you control them is with an open loop PWM signal. We are going to change those to a set of saber-tooth motor controllers which can be controlled by serial data communication in a closed loop, so there's error checking and we can get a much more robust communication system with our controller. For our communication system, we are going to be developing both Python and Java code for moving streams of bits between our robot and our central command system. This is mainly so we can monitor the autonomous system functionality. This is going to be very important for when we're testing our autonomous system and when we're developing it and when we're testing it. We are planning on, and really we already have, a number of graphical programs written in Java that are that can provide us feedback on the health of our autonomous system, on the activity of our autonomous system. But we really have to get our communication system from the robot to be able to communicate with that Java program that's running on our central command system. For our control system, we also have to implement our serial communication so that the motor controllers that we are going to be implementing on our testing platform, which use serial communication, such that we can communicate with those directly from our Raspberry Pi. We are hopefully not going to have to communicate serial information to an Arduino and then out to the controllers. We should hopefully be able to communicate that information directly from a Raspberry Pi. As far as the schedule, our next big date for testing and completion of testing of different systems is November 1st. We've agreed as a team that by November 1st we should be able to ping the control system on our robot. We should be able to have remote login for the control system on the robot, so pretty much remote login into our Raspberry Pi. And this is going to be a graphical system. And it's also important that this is going to be a graphical system that we can turn off when we're not using it. So during the competition, we don't always need graphics running on the Raspberry Pi. We are also going to have a Java virtual machine working on a Raspberry Pi, and we are going to start porting some existing autonomous Java code over to the Raspberry Pi. A good portion of the electrical team for this year's competition worked on this competition last year, and the team that worked on this last year developed a pretty sizable amount of Java code implementing autonomous functionality. We really have to gauge how much of that can actually be reused, but at the same time we want to gauge how much of it we are going to be able to reuse, but we also want to port as much of it as we possibly can over to our new control system. And then finally, we want to be able to directly control the robot manually with a joystick. So we hope to accomplish these goals by November 1st. That's the deadline, the goal that we have set as a team. So anyway, thank you so much for watching this presentation. If you would like to get in contact with me, my name is Mark Halberstadt, and my email is c.mark.halberstadt@temple.edu. And as well, if you have questions, please absolutely feel free to leave comments and leave questions in the WebEx posting. Thank you so much for watching, and I hope to see you in a future video. Thanks a lot.